Okay. So today we will spend time understanding these intervals, okay, in real numbers. Now, let's take a simple example. Okay, so if you take any two natural numbers, okay, suppose I take two natural numbers, A, B, they belong to natural numbers. And if A is, let's say, 2, B is 5, okay, B is 5. You don't use interval notation for natural numbers because between 2 and 5, you don't really have infinitely many natural numbers, right? If you take 2 and 5, all you have is 3 and 4. Okay, so there are only two numbers. But if A and B belong to real numbers, okay, if they belong to real numbers, if A is 2, B is 5, and then if you take 2 and 5, there are infinitely many real numbers. Okay, so you have infinitely many real numbers. Many real values. Okay. Now, that is the reason why the interval notation is used only for real numbers. Now, whenever you solve a problem, okay, algebraic problem, especially let's say areas like there's something known as a modulus function. Okay, I think you are aware of modulus function, right? Did you ever get modulus function?
Yes, sir.
Yeah, modulus function. And then instead of solving equalities, if you work with inequalities, okay, inequalities, there again, the solutions will not be few numbers. The solutions can be infinitely many values. Okay. So for example, if you have a quadratic equation, or why quadratic equation? Just take a simple linear equation. Okay. Suppose I have x plus 2 equal to 5. Okay. If I say x plus 2 equal to 5, and if I assume what kind of values can x take here if x plus 2 is equal to 5? It's a very simple equation.
3.
3, right? X is just 3. So there is only one value that satisfies this equation. But instead of equality, suppose if I say x plus 2 greater than 5, then how many values can satisfy this, let's say, inequation or inequality? Infinitely many, right? So what are they?
7.
Yeah, so starting from 7, okay, so 7 can be your answer. Then
9.
9 can be your answer. Can 7.5 be your answer?
Yes, sir. 10.
Okay, but is 7 is your answer?
Yes, sir. It is.
For this, is 7 is your answer? If I have x plus 2 equal to 5, 7 is your answer, right?
Yes.
7.5 is also an answer. Okay, but are there any answers which are less than 7?
6.
Okay, anything less than 6?
Yeah, 5.1.
5.1. But when you actually solved this x plus 2 equal to 5, how did you get 3?
Just sent to that side.
To that side, right? So even here we can do the same thing, right? So if you have x plus 2 greater than 5, can I say the idea is if I have x plus 2 greater than 5, if I add something on both sides,
Greater than 3.
the sign will remain same, right? If I subtract something from both sides, the sign will remain same. Do you guys understand? What you do in an equation, in an inequality also, the inequality will remain same when you add the same quantity on both sides, or you subtract the same quantity on both sides. Okay, for example, here x plus 2 greater than 5. So I'm actually subtracting 2 from both sides. Okay, I subtract 2 from both sides. So this greater than will still be valid here. Do you guys understand here? This greater than will still be valid. So the left hand side you have x, and the right hand side you have 5 minus 2, 3. So that means x can take any value which is greater than 3. Okay, so it can have values like 3, 3.1. No. It cannot be 3, 3.1, 3.2, 5, 6, 7. It can have any of these values. But another important thing here is now any value which is greater than 3 is going to satisfy this inequality. So, but how do you represent? I mean, you don't want to list all those numbers, right? Because there are infinitely many numbers. And the interval notation is helping you describe a set in a compact form. Okay, so you should treat it as a good thing, right? It is actually giving you a convenience to represent infinitely many numbers in a shorthand notation, right? So in this case, we are just saying that, okay, now my solution set. Okay, so you say that my solution set is given by 3 is not included here. Okay, because 3 is not included, you use that open bracket, the normal bracket, and then you place 3. Okay, so whenever you use this, what is this telling you is the number that is coming after that. Okay, so the number that is coming after that, 3 is not included. 3 is not included. And then anything after that is included. Okay, so any value which is even like very slightly greater than 3, that is included. And then after that, you put that comma, and then you know all values greater than 3 are included till a very large value. Okay, so that large value, we call it as infinity. Okay, so infinity is kind of a feeling that you have a very large number. Okay, so you just put that infinity symbol. You understand? So this is the interval notation. Okay, so this is the interval. Now, let's take another simple case. So instead of x plus 2 greater than 5, suppose if I have, let's say, x plus 2 greater than or equal to 5. In that case, what will happen? You
I will also be included.
So x will be greater than or equal to 3. Now,
We will.
it's a part of the solution. Okay, so 3 is also valid. In that case, instead of using this open bracket, you'll go with the closed bracket. That square bracket, you can also call it as a closed bracket. So then the solution set will be 3 till infinity. Now, but if you are using, let's say if you're writing down infinity, either the plus infinity or the minus infinity, you'll always place the open bracket or the normal one. Are you okay here?
Yes.
Okay. So this is the advantage. This is the advantage of using intervals. Now you need to understand that intervals are sets. I hope you get that idea. Okay, so interval is a set. Is a set of real numbers. Okay, and you always take the help of two numbers. Okay, so anytime you have an interval, in that interval there are always two numbers. Okay, so the beginning number and the end number. And then there are four possibilities, right? If you have two numbers, there are four possibilities, whether to include the beginning number or not. Okay, whether to include the end number or not. Okay, so those are the four possibilities. And after that, all the numbers in between those two numbers are definitely included. You get this idea? I hope it is clear. Okay. Now, to get more practice on this, what I will do is I'll give you very simple equations. Okay, very, very simple equations. Okay, first let us refresh your skill of solving quadratic equations. Okay. Let's say, 1 second. X square minus, let's say 5x plus 6 equal to 0. Okay, I'll pause for a few minutes. Now try to solve this equation. Okay, and x belongs to real numbers. Okay, x belongs to real numbers. Solve this equation first. Okay, so it is easy to solve, right?
Yes.
3 and 2 will satisfy. Now, how did you solve? You actually factorize this, right?
Yes.
So you try to take x square, and then that minus 5, I can write it as minus 3x and minus 2x plus 6 equal to 0. And then x into x minus 3 is common, 2 common. So x minus 3, this is equal to 0. And x minus 3 into x minus 2 equal to 0. Now you have a situation where the product of two quantities. Okay, so you have x minus 3 and x minus 2. The product of two quantities is equal. Okay, now I can actually call this x minus 2 as A and x minus 3 as A and x minus 2 as B. So when you do that, the product of A and B is 0. Okay, what does it mean? Let's say if the product of two numbers is 0, I can have cases, right? I can say that maybe A is 0, but B is not, right? Or A is not equal to 0, but B is 0. Or a third case is like both are zeros, right? So that is why you say when x minus 3 multiplied by x minus 2 is 0, you say that, okay, x is 3 or x is 2. Now, whenever you have a or situation, either 3 is the solution or 2 is the solution, both are the solutions. Okay, so that is why 2 and 3, they become part of the solution set for this quadratic equation. Okay, so now when you write solution set for 2 and 3, you don't use an interval notation here because you have only two values here. In that case, how do you actually write the solution set? This is something that you did in 10th class, right? The solution set that you write here will include curly braces. Okay, you don't use those brackets which are used to represent the intervals. You use curly braces and then you place 2 and 3. Basically, you are like showing a set kind of in roster form. Okay, your solution set is a set of values which satisfy the quadratic equation in roster form. Okay, now instead of a quadratic equation, if you have, let's say, a higher order equation, you might have more values satisfying the equation. Now, let us move to inequalities. Okay, so from quadratic equation, let's convert the same thing into a quadratic inequality. So now pay attention here. Instead of equal to sign, okay, I can change that to greater than, okay, or greater than or equal to, okay, or less than or equal to. I can do that, right? So let's look at this. So if I have x square minus 5x plus 6 is greater than 0, suppose. Okay, if I have x. Now then what will happen? You will try to solve this as if you're solving your quadratic equation. You try to factorize it if it is possible. Okay, in this case, it is definitely possible to factorize it. You factorize it. Okay, like we have done here. So you factorize it and then get the factors. You have x minus 2 and x minus 3 is greater than 0, right? Now, if you consider x minus 2 as A and x minus 3 as B, okay, so this is A and this is B. What kind of situation we are in now? Okay, you have product of two quantities. We are saying their product should be positive, greater than 0. And A and B are real values, right? A and B are taking real values. So now, when is the product of two real numbers positive? What are the possibilities? Both of them can be positive numbers,
Yes, sir.
or both of them can be
Negative.
negative numbers. Very good. So here we can say that, okay, case 1 is like either A is greater than 0 or B is greater than 0. Can I say or should I say and? What do you think is appropriate here?
And will be appropriate.
Very good. Okay, here or is not correct. Okay, so this will be and. Okay, so this is one possibility. And the second possibility is what? A is less than 0 and B is less than 0. But for these two, I can say that I have a or condition, right? I have a or condition. Do we get this idea?
Yes.
No. So when you actually write cases like this, it is sometimes actually difficult to, let's say, quickly arrive at the solution set. Okay. So what generally is done in these cases, okay, in these inequalities cases is, you first try to identify when is this left-hand side becoming 0. Okay, that means you are actually solving for the equation part. Now, when is this becoming 0? The left-hand side is becoming 0 when x is equal to 2 and x is equal to 3, right? We have seen this here. Okay, the left-hand side becomes 0 when x is 2 or x is 3. Now, 2 and 3 are real values. You can actually show them on the real number line. Okay, now it is recommended that, okay, you draw that real number line. Okay, a rough sketch of the real number line. So if I show the real number line and then put those two numbers. Okay, so let's say I'm placing 2 here and then I'm placing 3 here. Now, first look at 2 and 3. Okay, now if I'm interested in solving this greater than, do you think x is equal to 2 will satisfy this inequality? Will it satisfy? If you put x is equal to 2, whatever I get on the left-hand side, will it be greater than 0? What do you think, guys? If I substitute 2, will it be greater than 0?
No.
It will not be, right? So that means 2 is not a solution, right? We understand. So 2 is not a solution for this inequality. 2 is not a solution. How about 3? Do you think 3 is a solution?
No, sir.
3 is also not a solution. Okay, because 2 and 3 are not a solution, when you are using the number line, you place open circles. Okay, you place open circles there. Now, what are those open circles telling us? They're telling us that, okay, because there is an open circle, that means it's like a gap. It's like a gap, a gadda, na? Because if you take an interval is basically a continuous number line, okay, representing that there are infinitely many values. The moment you put a gap, gadda, like gadda right there, so that means that number is not going to satisfy this inequality. So usko ignore kar rahe ho aap. Okay, so 2 and 3 are ignored. Now think about this. If you take any value to the right of 3, suppose, any value to the right of 3 is going to make your b, which is x minus 3, positive, right?
Yes, sir.
Because 3 is greater than 2, even a, which is x minus 2, that will also be greater than 0.
Yes.
So that means I have two positive values. A is greater than 0, b is greater than 0. Okay, because a is greater than 0, b is greater than 0, my inequality is going to be okay. It gets satisfied. So that means can I claim that any value, okay, after 3, but not 3, any value after 3 will be my solution. I can take any of those things. Are you getting this idea? Any value after 3 will be my solution.
Yes, sir.
Understand, Harsha?
Sir, the same goes for the x minus 2, right? So if any solution is
When you say
greater than,
minus 2 in the sense less than 2, you're saying.
yeah, sir, minus 2. If it is greater than 2,
Why,
it's also satisfied.
why minus 2?
No, sir, I'm saying like here x in the A, sir, if x is greater than 2, it will also same like satisfy the same as my B, right, sir?
X is greater than 2, you're saying. Are you looking at this middle part?
The A1, sir, the A1.
Acha, A1. Yeah, it will satisfy now. Because, yes. That is what I'm saying. Okay, you take any value from here, because it is greater than 3, obviously this x minus 2 will become positive, right? When you substitute any number greater than 3, the first factor will become positive, greater than 0. The second factor will become positive. So positive into positive, you'll get a value which is positive. So that means for this inequality, you take any value from here will satisfy. That means any of these values, any of these real numbers form the solution set. Okay. And how about, let's say, less than 2? Suppose if I take,
Less than,
let's say, less than 2. If I take these values, less than 2.
if it is a negative,
Think about it. Let's say, for example, I'll take some example. Maybe the convenient example, which is less than 2, is actually 0, right? A convenient example is 0. So the moment you take x is equal to 0, what is x minus 2? X minus 2 will be minus 2.
yes, sir.
And x minus 3 will be minus 3. So what is minus 2 into minus 3?
Minus 6, sorry, sir, 6, 6. Just
6, which is greater than 0.
yes, sir.
Right? So that means if you take any value which is less than 2, it is going to make the first factor negative. Because you're taking a value less than 2 and then the first factor is negative ho raha hai, so second factor obviously negative ho jayega. And then negative into negative, ye second case mil gaya na hame. Negative into negative is again positive. So that means here, what are we getting? Now, any value which is less than 2 is also a solution.
Yes.
Okay, I can take any numbers which is less than 2 will be my solution. Any number which is greater than 3 is my solution. Okay, but now think about the values between 2 and 3. Do you think they will satisfy this inequality if you take any number between 2 and 3?
No, I guess.
Why? Why not? What is your reason?
Because they are less than 2 or maybe less than 3 like this.
Yeah, if you take any number between, let's say if I take some number here, what is a convenient number? Maybe like a 2.5, okay? What will this 2.5 do is, it will make the first factor positive, but the second factor will be negative, right? Because x will be less than 3. So 2.5 minus 3, for example, I mean, we will see that, okay? When you take x as 2.5, my x minus 2 will be 2.5 minus 2, which is 0.5, which is positive. But x minus 3 will become minus 0.5. So now you have a negative number getting multiplied with a positive number. So negative into positive will give you what? Negative. So that means the left-hand side will be less than 0. But what do you want? You want greater than 0. Are you getting this?
Yes, sir.
But I have taken a specific value right here. But can you see that you can take any value between 2 and 3 and it will not satisfy this inequality, right? If you take any value, it will not satisfy this greater than equal to 0. You will actually get less than or equal to 0, which you don't want. Okay, so that means what we are trying to say here is if you take any value here, including 2 and 3, this is not a solution set, not a solution set. Okay, now this is a solution set and
Yes,
this
sir.
is a solution set. Okay, but there are so many numbers, right? There are so many numbers. How do you show all these numbers? So that is again where we are taking the help of intervals. Okay, so the intervals are there to help us. This is my point here. Okay, there is a reason why we have those shorthand notations, the interval notations, because there are many values which will become part of the solution when you solve such inequalities. Mathematicians have come up with this nice idea. Okay, we should actually treat it as a nice idea to help us. So now, how do you represent the solution set here? The solution set will be now anything greater than 3 is okay, but 3 is not included. So what kind of bracket will I use?
Curve bracket.
Square or
Square
open?
bracket.
The normal one. Square or open?
Normal one, sir. Curve
Normal
bracket.
one, right? So the
Curve
open,
one.
closed one. Because 3 is not included. Remember, I put a circle, open circle there. No, open circle is like a gap. So you use the normal bracket 3 and then any value after that is okay. So you put an infinity, or how do you represent here? Anything less than 2. So 2 is the higher at the higher end. So you put minus infinity to 2. Again 2 close bracket. But yahan par again we want to use the set understanding, which I wanted to teach you guys. But you know that union thing. Did you learn union intersection in 10th class? Yes?
No, sir. No.
No? Okay. I'll do one thing. Okay. Now you know that there are 2 sets here, right? This is one set and this is another set. Now your solutions can come from either of the sets. So you are going to combine them. Okay. So combination is like uniting, right? Combining is uniting, making union, right? Combining, uniting. Okay. So it's like making a union. I mean, we will look at that union, intersection, those kind of things in the next class. But right now, use a symbol. Okay, so you have a symbol U. U stands for union. Okay, so if you take 2 sets, for example, I'll come back to that solution set. So suppose I have A with these numbers 1, 2, 3. Okay, so I have B with 2, 3, 4. Okay, so when you take A union B, what you do is you include all the elements from set A. You also include all the elements from set B, but wherever you see common values, you include them only once.
So like there are no duplicates.
Yes. So you have 1, 2,
So it will be 1, 2, 3, 4.
1, 2, 3, 4. Okay. Now this is about union. There is another thing called intersection or common part. Okay. So if you have a common part or intersection. So for the intersection, there is a ulta cup wala symbol. Okay. So suppose for the two sets, are there any common elements? We have 2 and 3 common, right?
Yes, sir.
So in this case, when you take A intersection B, you consider only 2 and 3. Okay, this is something I wanted to teach today, but it's okay. I think if you understand this much, it is good enough for us. It will help us with the intervals. So now when you go back to our problem, the inequality, now we are saying that, okay, this set is also this set or this set will become the solution set. So when you actually represent the solution set, you write it finally like this. So the final solution, you write it this way. Final solution minus infinity to, you place union because you are combining them, right? Union and then 3 and infinity. So this is your final answer. You guys understand? By just placing, let's say, changing equal to sign to greater than 0, the problem has changed drastically. You get the point?
Yes.
Okay. So now I'll do one thing. Okay. You have any questions here?
No, sir.
Okay. You can do one more thing. Okay. So you can do one more thing. What you can do is whenever you draw this number line, okay, whenever you draw this number line, wherever the left hand side is becoming 0, those values are called critical points. For example, this 2 and 3, they're called critical points. And if the power of factors, okay, so when you have this x minus 2, x minus 3, if the power of factors is 1 or any odd number, okay, right now, let us not get into difficult inequality problems. So I will be exposing you to simpler ones only, okay, where each factor power will be only 1. Okay, if it is 1, you can safely say that once you get the rightmost critical value, you take any value after that, the left hand side will be positive. Okay, so you can just simply say, okay, so this will be positive side. And after that, it will be negative. And after that, it will be positive. Okay, and then greater than 0 is telling you are looking at positive values. So that means this becomes your solution and this becomes your solution. You get the point? So I will show you how to, let's say, approach this. Now, if you are really solving, let's say, JEE problems later on, you would be doing this. Okay, so you would be doing this. But right now, we'll take simpler cases. Suppose I'll take another problem. Let's say x square minus, let's say 7x plus 12 is greater than 0. Now, how do I solve this? I'll try to solve it as if I don't have the inequality, I have equality. So if I look at the left hand side, I will equate that to 0 first. Okay, now if I factorize this, I know 12 can be broken down into 4 into 3. And then adding 4 and 3, I get 7. So you know that this is easily done. So minus 4x minus 3x plus 12 equal to 0. So x
3.
minus 4 minus 3 and then x minus 4. So what are the factors here? X minus 3 and x minus 4. So for these two values, x is equal to 3 and x is equal to 4, I don't have an inequality. I have an equality. So that is why these values 3 and 4 are taken as critical points. Okay, so on the number line, you put those critical points first. Okay, you do that first. And then, because I'm looking at just greater than, okay, strictly, I want the left-hand side to be positive, greater than 0. But if I take 3 and 4, it will make it 0. Okay, it will make the right-hand side 0. So that is why these values are not included. So you put an open circle just to tell you that, okay, I don't want to consider them as solutions. Okay, so they are not my solution. And then you will realize that if you take anything greater than 4, you will get the right, you will make the right hand side positive, matlab greater than 0. And then after that, alternatively, each region, each interval between 4 and 3 or 3 and 4, it will be negative. And again, if you come to the left, it will be positive. So you can directly say that your solution set, okay, either you can write solution set equal to, or there's another thing, x values belong to, right? Both mean the same thing. Either you have a solution set, or you're using a variable saying that, okay, this belongs to this set. Now, what are the answers here? Anything which is
Minus infinity and 3.
very good. So minus infinity to 3. Is 3 included?
No, sir.
No. So you put an open bracket and then you say union, and then you do 4 and then
And
infinity.
infinity.
Infinity. So that is how you get the intervals here. Are we okay here?
Yes.
Okay. Okay, so let's talk about it. So what is the solution set here?
You want me to say that section?
What is that?
Like in intervals. Sir, that
Yeah, you can tell an interval. Yes, you need to tell an interval. What is
x
your answer?
belongs to x belongs to infinity, 1 and the square brackets.
X belongs to infinity,
Minus infinity.
minus infinity, and then
Sir, that brackets.
okay, bracket, okay, then
And 2, 1, sir.
2, 1, okay, then
Square brackets.
square bracket, okay,
And then that u thing, sir.
union, okay,
And then square bracket 10
uh-huh,
and infinity
uh,
and bracket.
okay. Om, do you agree with this answer?
Yes, sir.
Okay, that means you guys did not pay attention to this less than or equal to.
Sir, that's why I added the square brackets. Sir, 1 is included in it.
But this is not the answer. Look at it carefully. 1 second. Aram say, okay. Okay. You know that the factors are okay. So you have x minus 1 and x minus 10 is less than or equal to 0. Right. Now you have a situation where the product of two quantities is less than or equal to 0. Okay, A and B less than or equal to 0. Now, when is A into B? Okay, A into B less than or equal to 0. One of them should be negative, right?
Yeah, sir.
You understand?
Yes, sir.
Either of them can be 0. 0 is also okay. But if they are not zeros, then one of them should be negative. Okay, you can have cases, right? A is 0 or B is 0. Or if they are not 0, suppose A is not equal to 0, B is not equal to 0, then if one is less than 0, the other has to be greater than 0. If A is greater than 0, then B has to be less than 0. Only then you will get less than or equal to 0, right?
Yes, sir.
So what are the critical points? What are critical points here?
10 and 1.
10 and okay. Now, are they included?
Sir, they are included.
Okay, so they will, because equal to is also okay. So they're included. So they use a closed circle here. So closed circle it tells you that, okay, these values are okay for me. They are part of the solution. Now look at this. You take any value which is greater than 10, what will it make? It will make x minus 10 greater than 0.
Yes.
If it makes x minus 10 greater than 0, will it not make x minus 1 greater than 0?
Yes. We should use
So
very
that
simple.
here, every value will be positive. That means it will be greater than 0. So what that tells us is this is not a solution for me.
Yes, we should use minus infinity.
But minus infinity also, let us see. If you take any value less than 1, what will happen? Your x minus 1 will become negative.
Yes, sir. Correct.
Then your x minus 10, will it become negative or it will be positive?
Positive.
Are
So
they-
negative.
Negative into negative will be what?
Positive. Sir.
What do you want? But
Negative. Sir.
negative. So that means this is also positive. So only the values in between will make negative, right?
Yes, sir.
So what is your solution set really? That is the
Yes.
solution set.
Yes.
This is also not a solution. Om, are you getting what I'm saying? So your x actually belongs to what? Now tell me, what does your x belong to?
1 minute. Belongs to 1 and 10.
1 and 10. Are they included?
Yes. Yes, sir.
Yes, they are included. So 1 and 10. So that is how you represent your solutions. Just get the idea here. Understand? Okay. Now, simple summary. Okay, so let's say now when I'm like explaining this or summarizing this, I'm assuming I have two real values, A, B. They belong to, let's say, real number set, so real values. And A is assumed to be smaller than B. Okay, I can have cases, right? I can say x minus A, when I have a quadratic inequality, x minus B, I can get greater than 0. So when I get greater than 0, I know the critical points are A and B. Critical points are A and B, but they are not included. Okay, so if I take any value greater than B, okay, so any value which is greater than B, this will be positive. Any value after that, between here to here, this is negative, and this is positive.
Positive.
If I'm looking at greater than 0, for me, anything that is greater than B is okay. And then this is also okay. So my solutions will be either x is less than A or x is greater than B. Okay, x is less than A or x is greater than B. So to represent this, you represent it with your intervals. Okay, so you write minus infinity to A is not included, and then union B to infinity. You're okay? So here we're not using numbers, we are just using this A and B, which you also can call parameters. Okay, so you don't know the values, but yeah, this is the general setup. But if you have, let's say, greater than sign, then what do? If x minus A into x minus B is greater than or equal to 0, you still do the same thing. Okay, but you use closed circles to tell us that A and B are included now. Okay, so if you take any value greater than B, it will be positive, and after that it will be negative. And then again, this will be positive. So this is my solution, including A and B. So you write, okay, x less than or equal to A will work, or if x is greater than or equal to B will also work. So how do you write your solution set? It will be now minus infinity to A, but A is included, union B to infinity. Okay. Now, instead of greater than or equal to, suppose you have less than. Okay, so x minus A to x minus B is less than 0, then what will happen? Your critical points are still same.
Yes.
But what, let's say, becomes your solution, that is different. Okay, so you still have open circles here because that is less than, equal to nahi hai. And then if you go beyond B, it is positive, but you don't want that, right? That's not your solution. If you go to the left of A, again it will become positive, but you don't want that. So what is your solution? One which is between. So your X has to be between A and B, less than, but A and B are not included. So how do you represent this? You show, okay, X belongs to A and B. That's the interval notation. Now, this is like strictly less than 0, but if you have, let's say, less than or equal to 0, yeah, so less than or equal to 0, then what do you have? You put the closed circle. And then again, what do you have here? This is positive. This is positive. You can go from right side. Okay. Rightmost region, what is happening? This A and B are dividing the real number line into 3 parts, right? So you have a part which is greater than B. You have a part between A and B. You have a part which is less than A. Now, the rightmost region, from the rightmost region, you take any values. Okay, you doesn't any value you take, it is going to make this inequality positive. So because it is going to make this left-hand side value positive, but you want either 0 or less than 0. So that cannot become your solution set. Okay, so you ignore that. And similarly, the same thing happens to the region which is less than A. Okay, so if you take any value, your left-hand side becomes positive, but you don't want it. Okay, so that is why that is also not your solution. So your solution is actually right in the middle. Okay, but this time the points A and B, we are using those closed circles to indicate that they're okay for me. Okay, so I am happy with those values. So your solution will be equal to, less than or equal to. So X belongs to this time, you have A, comma, B. Okay, are you getting comfortable with the intervals now?
Yes.
Okay. So you want to look at one more, not a very difficult one, but I'll test you with one simple problem. Can I? Okay, so let me give you some time. Okay, so let's say I have X plus 3 divided by, now this time I'm dividing, okay? X plus 3 divided by X minus 2 is greater than 0. Okay, X belongs to R. Can you solve this? Okay, I'll pause for a while. Okay, so in this case, you are looking at, let's say if I treat the numerator as A and the denominator as B, we are looking at A divided by B greater than 0, right? A divided by greater than 0. So your critical points are still, let's say, X plus 3, when it is 0, you get minus 3. And then X minus 2, 0, you get 2. Critical points are still 2 and 3, but how you work them will be very important. Okay, so critical points are still, 2 and 3 or
Minus 3 and 2.
minus 3 and 2. Yeah, sorry, minus 3 and 2. So those are the critical points. But now you have to be careful here. When you have A divided by B greater than 0, first of all, can your B be 0? Can your B be 0?
Yes,
Yes,
sir.
sir.
Okay, what happens when your B is 0? A divided by 0, what will that be? Will it be greater than 0?
Yeah.
So
Oh.
what's
See, A divided by 0, will it be greater than 0? A is some number. If I divide by 0, will I get something which is greater than 0?
if A is not negative, sir?
Okay, if A is not negative, then it will be greater than 0. So suppose A is 2, 2 by 0. What is
Yes,
2?
sir.
Will it be
Yes.
0?
Yes, sir, it will be greater than 0.
But what do you mean by 2 divided by 0?
Sorry, sir, it's not a fraction.
Okay, it is undefined, right? You cannot divide by 0.
Yes.
Okay, if it is slightly greater than 0, if it is slightly greater than 0, you can say I'll get a very large value. Okay, instead of 0, if it is slightly greater than 0, you can say I have a very large value. If it is less than 0, I can say I'll get a very small value. So division by 0 is undefined. So that is why when you take the critical points, x minus 2 equal to 0, you cannot take, okay, 2. Oh, okay. So now you understand that 2 is not really included. So you take the number line, you put minus 3 and 2. Both of them are not included. Okay. But again, look at this. If you take any number greater than 2, what will happen? Your denominator will be greater than 0.
Yes, sir.
Okay. And your numerator will be greater than 0. Okay. So something greater than 0 divided by something greater than 0, you will get greater than 0, right?
Yes, yes.
Side is positive.
Sir.
Okay. And then again, if you go to the region which is less than minus 3, what will happen? Your numerator will become negative,
The denominator
will also become negative. So negative by negative will give you what?
positive.
Positive. So that means this becomes positive, right? And then in between, what will happen?
Between will be negative, sir, or undefined. Sir.
Will be negative, right? So that means what will be your solution set then? What is your solution set?
Minus negative and
So this is your solution set. This is your solution set, and this is your solution set. So you can say that minus infinity to minus 3, but is 3 included? Minus 3 included?
no, sir.
No. And then union, you can do 2 and infinity. You're getting?
Yes, sir.
Om, are you okay?
Yes, sir, I got it.
Okay. Now one small change. Okay. So instead of greater than 0, if I make it greater than or equal to 0, what do you think will happen?
Minus 3 and 2 will also be included.
Okay. But if you include 2, what will happen?
Uh,
You include minus 2 or normal positive.
You can include minus 3, but you cannot include 2 because you still don't want your denominator 0. You get the point? See,
yes.
you want this to be greater than or equal to 0. But the problem is, if you put x is equal to 2, I get a by 0 wala case, na, which is not good.
Yes.
You're okay?
Yes.
So that is why your x cannot be 2. X cannot be 2. So your solutions will be what? Minus infinity, minus 3 will be included. Because your numerator can be 0. Okay. So your solutions will be minus infinity to minus 3 and then 2 to infinity. You're okay? Okay. So I think we'll do one thing is maybe we'll stop here.